Let's talk about benzene molecule in this video. Benzene has a molecular formula C6H6. Okay, and it is a cyclic compound. So what does it look like? It looks like this. Okay, for now let's just take it that way. Okay, so it has a carbon ring that has 6 carbons, and there are 3 double bonds like this. Okay, when people and of course the rest of the bonds are filled by hydrogens. So when scientists were working on this structure, you have to remember that carbon-carbon and carbon-carbon double bonds and triple bonds, the bond lengths are different. Carbon-carbon bond, single bond, is longer bond compared to carbon-carbon double bond, which is even longer compared to carbon-carbon triple bond. So if benzene had a structure like this with alternating double bonds, if the bond lengths were true, and these are experimentally proved trends, so it's carbon-carbon single bond is longer than a carbon-carbon double bond, and it is a proven, experimentally proven fact. So if that was the case, we should have observed something like this, right? Where there is carbon-carbon single bond like this, and carbon-carbon double bond, it should have been shorter, and single bond, and then double bond, and single bond, and a double bond, right? So alternative short and long bond lengths, right? But they did not notice that. What they noticed was that bond lengths between all carbons are same. So with a lot of experiments, they realized and they discovered that benzene is a structure which can be represented like this, or it can be represented like this, and if you notice, let me just make a small correction here. Okay, and if you notice, you will see that carbon double bond is between 1 and 2 here, and it's between 2 and 3 here, right? It can be represented in both these ways. What does this mean? This means that these two are resonance structures, and the actual structure is a resonance hybrid of both these structures, which can be represented like this. So what does that resonance structure mean? What does this hybrid mean? Hybrid means that these electrons that we are showing, the double bond electrons that we are showing here, they are not localized. In fact, if there is a sample of benzene, all the molecules in that sample will have electrons that are not just localized here, they are not staying here, but every instant they keep switching between these two structures. So the actual structure is a hybrid of both of these. This is like how we say that a mule, right, is a hybrid between a horse and a donkey, right? So what does that mean when we say the hybrid, right? So it has characteristics of both. So a sample of benzene will have characteristics of this structure and this structure as well, and this resonance makes this benzene very stable.